we have at last come home.
Welcome to the planet Earth, a place with blue nitrogen skies, oceans of liquid water, cool forests, soft meadows, a world positively rippling with life. From the cosmic perspective, it is, for the moment, unique. The only world in which we know with certainty that the matter of the cosmos has become alive and aware. There must be many such worlds scattered through space, but our search for them begins here, with the accumulated wisdom of the men and women of our species, acquired at great cost over 1 million years.
There was once a time when our little planet seemed immense, when it was the only world we could explore. Its true size was first worked out in a simple and ingenious way by a man who lived here in Egypt in the 3rd century BC.
This tower may have been a communications tower, part of a network running along the North African coast by which signal bonfires were used to communicate messages of state. It also may have been used as a lighthouse, a navigational beacon for sailing ships out there in the Mediterranean Sea. It is about 50 kilometers west of what was once one of the great cities of the world, Alexandria. In Alexandria, at that time, there lived a man named Eratosthenes. One of his envious contemporaries called him Beta, the second letter of the Greek alphabet, because, he said, Eratosthenes was second best in the world in everything. But it seems clear that in many fields, Eratosthenes was alpha. He was an astronomer, historian, geographer, philosopher, poet, theater critic, and mathematician. He was also the chief librarian of the great library of Alexandria. And one day, while reading a papyrus book in the library, he came upon a curious account.
Far to the south, he read, at the frontier outpost of Syene, something notable could be seen on the longest day of the year. On June 21st, the shadows of a temple column or a vertical stick would grow shorter as noon approached. And as the hours crept towards midday, the sun's rays would slither down the sides of a deep well, which on other days would remain in shadow. And then, precisely at noon, columns would cast no shadows, and the sun would shine directly down into the water of the well. At that moment, the sun was exactly overhead.
It was an observation that someone else might easily have ignored. Sticks, shadows, reflections in wells, the position of the sun, simple, everyday matters of what possible importance might they be. But Eratosthenes was a scientist, and his contemplation of these homely matters changed the world. In a way, made the world. Because Eratosthenes had the presence of mind to experiment, to actually ask whether, back here, near Alexandria, a stick cast a shadow near noon on June the 21st. And it turns out, sticks do. An overly skeptical person might have said that the report from Syene was in error, but it's an absolutely straightforward observation. Why would anyone lie on such a trivial matter? Eratosthenes asked himself how it could be that at the same moment, a stick in Syene would cast no shadow, and a stick in Alexandria, 800 kilometers to the north, would cast a very definite shadow. Here's a map of ancient Egypt. I've inserted two sticks, or obelisks, one up here in Alexandria and one down here in Syene. Now, if at a certain moment each stick casts no shadow at all, that's perfectly easy to understand, provided the Earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat Earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the Earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the Earth. Sticks at different angles to the sun's rays will cast shadows at different lengths. For the observed difference in the shadow lengths, the distance between Alexandria and Syene had to be about 7 degrees along the surface of the Earth. By that I mean, if you imagine these sticks extending all the way down to the center of the Earth, they would there intersect at an angle of about 7 degrees. Well, 7 degrees is something like a 50th of the full circumference of the Earth, 360 degrees. Eratosthenes knew the distance between Alexandria and Syene. He knew it was 800 kilometers. Why? Because he hired a man to pace out the entire distance so that he could perform the calculation I'm talking about. Now, 800 kilometers times 50 is 40,000 kilometers. So that must be the circumference of the Earth. That's how far it is to go once around the Earth. That's the right answer. Eratosthenes' only tools were sticks, eyes, feet, and brains, plus a zest for experiment. With those tools, he correctly deduced the circumference of the Earth to high precision, with an error of only a few percent. That's pretty good figuring for 2,200 years ago.
Then, as now, the Mediterranean was teeming with ships, merchantmen, fishing vessels, naval flotillas, but there were also courageous voyages into the unknown.
400 years before Eratosthenes, Africa was circumnavigated by a Phoenician fleet in the employ of the Egyptian pharaoh Necho. They set sail, probably in boats as frail and open as these, out from the Red Sea, down the east coast of Africa, up into the Atlantic, and then back through the Mediterranean. That epic journey took 3 years, about as long as it takes Voyager to journey from Earth to Saturn. After Eratosthenes, some may have attempted to circumnavigate the Earth, but until the time of Magellan, no one succeeded. What tales of adventure and daring must earlier have been told as sailors and navigators, practical men of the world, gambled their lives on the mathematics of a scientist from ancient Alexandria.
Today, Alexandria shows few traces of its ancient glory, of the days when Eratosthenes walked its broad avenues. Over the centuries, waves of conquerors converted its palaces and temples into castles and churches, then into minarets and mosques. The city was chosen to be the capital of his empire by Alexander the Great on a winter's afternoon in 331 BC. A century later, it had become the greatest city of the world. Each successive civilization has left its mark. But what now remains of the marble city of Alexander's dream? Alexandria is still a thriving marketplace, still a crossroads for the peoples of the Near East. But once it was radiant with self-confidence, certain of its power. Can you recapture a vanished epoch from a few broken statues and scraps of ancient manuscripts?
In Alexandria, there was an immense library and an associated research institute, and in them worked the finest minds in the ancient world. Of that legendary library, all that survives is this dank and forgotten cellar. It's in the library annex, the Serapeum, which was once a temple, but was later reconsecrated to knowledge. These few moldering shelves, probably once in a basement storage room, are its only physical remains. But this place was once the brain and glory of the greatest city on the planet Earth.
If I could travel back into time, this is the place I would visit. The Library of Alexandria at its height 2,000 years ago. Here, in an important sense, began the intellectual adventure which has led us into space. All the knowledge in the ancient world was once within these marble walls. In the Great Hall, there may have been a mural of Alexander with the crook and flail and ceremonial headdress of the pharaohs of ancient Egypt. This library was a citadel of human consciousness, a beacon on our journey to the stars.
It was the first true research institute in the history of the world. And what did they study? They studied everything, the entire cosmos. Cosmos is a Greek word for the order of the universe. In a way, it's the opposite of chaos. It implies a deep interconnectedness of all things, the intricate and subtle way that the universe is put together. Genius flourished here. In addition to Eratosthenes, there was the astronomer Hipparchus, who mapped the constellations and established the brightness of the stars. And there was Euclid, who brilliantly systematized geometry, who told his king, who was struggling with some difficult problem in mathematics, that there was no royal road to geometry. There was Dionysius of Thrace, the man who defined the parts of speech, nouns, verbs, and so on, who did for language, in a way, what Euclid did for geometry. There was Herophilus, a physiologist who identified the brain rather than the heart as the seat of intelligence. There was Archimedes, the greatest mechanical genius until the time of Leonardo da Vinci. And there was the astronomer Ptolemy, who compiled much of what today is the pseudoscience of astrology. His Earth-centered universe held sway for 1,500 years, showing that intellectual brilliance is no guarantee against being dead wrong. And among these great men, there was also a great woman. Her name was Hypatia. She was a mathematician and an astronomer, the last light of the library, whose martyrdom is bound up with the destruction of this place 7 centuries after it was founded.
Look at this place. The Greek kings of Egypt, who succeeded Alexander, regarded advances in science, literature, and medicine as among the treasures of the empire. For centuries, they generously supported research and scholarship, an enlightenment shared by few heads of state then or now. Off this great hall were 10 large research laboratories. There were fountains and colonnades, botanical gardens, and even a zoo with animals from India and sub-Saharan Africa. There were dissecting rooms and an astronomical observatory.
But the treasure of the library, consecrated to the god Serapis, built in the city of Alexander, was its collection of books. The organizers of the library combed all the cultures and languages of the world for books. They sent agents abroad to buy up libraries. Commercial ships docking in Alexandria harbor were searched by the police, not for contraband, but for books. The scrolls were borrowed, copied, and returned to their owners. Until studied, these scrolls were collected in great stacks called books from the ships. Accurate numbers are difficult to come by, but it seems that the library contained at its peak nearly 1 million scrolls. The papyrus reed grows in Egypt. It's the origin of our word for paper. And each of those 1 million volumes which once existed in this library were handwritten on papyrus manuscript scrolls. What happened to all those books? Well, the classical civilization that created them disintegrated. The library itself was destroyed. Only a small fraction of the works survived. And as for the rest, we are left only with pathetic, scattered fragments. But how tantalizing those remaining bits and pieces are. For example, we know that there once existed here a book by the astronomer Aristarchus of Samos, who apparently argued that the Earth was one of the planets, that like the other planets, it orbits the sun, and that the stars are enormously far away. All absolutely correct. But we had to wait nearly 2,000 years for these facts to be rediscovered. The astronomy stacks of the Alexandria Library. Hipparchus, Ptolemaeus. Here we are. Aristarchus. This is the book. How I'd love to be able to read this book. To know how Aristarchus figured it out. But it's gone, utterly and forever. If we multiply our sense of loss for this work of Aristarchus by 100,000, we begin to appreciate the grandeur of the achievement of classical civilization and the tragedy of its destruction. We have far surpassed the science known to the ancient world, but there are irreparable gaps in our historical knowledge. Imagine what mysteries of the past could be solved with a borrower's card to this library. For example, we know of a 3-volume history of the world, now lost, written by a Babylonian priest named Berosus. Volume 1 dealt with the interval from the creation of the world to the Great Flood, a period that he took to be 432,000 years, or about 100 times longer than the Old Testament chronology. What wonders were in the books of Berosus. But why have I brought you across 2,000 years to the Library of Alexandria? Because this was when and where we humans first collected seriously and systematically the knowledge of the world. This is the Earth as Eratosthenes knew it, a tiny spherical world afloat in an immensity of space and time. We were at long last beginning to find our true bearings in the cosmos. The scientists of antiquity took the first and most important steps in that direction before their civilization fell apart. But after the Dark Ages, it was by and large the rediscovery of the works of these scholars done here that made the Renaissance possible and thereby powerfully influenced our own culture. When in the 15th century Europe was at last ready to awaken from its long sleep, it picked up some of the tools, the books, and the concepts laid down here more than 1,000 years before.
By 1600, the long-forgotten ideas of Aristarchus had been rediscovered. Johannes Kepler constructed elaborate models to understand the motion and arrangement of the planets, the clockwork of the heavens. And at night, he dreamt of traveling to the moon. His principal scientific tools were the mathematics of the Alexandrian library and an unswerving respect for the facts, however disquieting they might be. His story and the story of the scientists who came after him are also part of our voyage. 70 years later, the sun-centered universe of Aristarchus and Copernicus was widely accepted in the Europe of the Enlightenment. The idea arose that the planets were worlds, governed by laws of nature, and scientific speculation turned to the motions of the stars. The clockwork in the heavens was imitated by the watchmakers of Earth. Precise timekeeping permitted great sailing ship voyages of exploration and discovery, which bound up the Earth. This was a time when free inquiry was valued once again. 250 years later, the Earth was all explored. New adventurers now looked to the planets and the stars. The galaxies were recognized as great aggregates of stars, island universes, millions of light years away. In the 1920s, astronomers had begun to measure the speeds of distant galaxies.
What time is it?
7:15.
All right, lights out, please.
They found that the galaxies were flying away from one another. To the astonishment of everyone, the entire universe was expanding. We had begun to plumb the true depths of time and space. The long collective enterprise of science has revealed a universe some 15 billion years old, the time since the explosive birth of the cosmos, the Big Bang. The cosmic calendar compresses the local history of the universe into a single year. If the universe began on January 1st, it was not until May that the Milky Way formed. Other planetary systems may have appeared in June, July, and August, but our sun and Earth not until mid-September. Life arose soon after. Everything humans have ever done occurred in that bright speck at the lower right of the cosmic calendar. The Big Bang is at upper left, in the first second of January 1st. 15 billion years later is our present time, the last second of December 31st. Every month is 1.25 billion years long. Each day represents 40 million years. Each second stands for some 500 years of our history, the blinking of an eye in the drama of cosmic time. At this scale, the cosmic calendar is the size of a football field, but all of human history would occupy an area the size of my hand. We're just beginning to trace the long and tortuous path which began with the primeval fireball and led to the condensation of matter, gas, dust, stars, galaxies, and at least in our little nook of the universe, planets and life, intelligence, and inquisitive men and women. We've emerged so recently that the familiar events of our recorded history occupy only the last seconds of the last minute of December 31st. Some critical events for the human species, however, began much earlier, minutes earlier. So we change our scale from months to minutes. Down here, the first humans made their debut around 10:30 p.m. on December 31st. And with the passing of every cosmic minute, each minute 30,000 years long, we began the arduous journey towards understanding where we live and who we are. 11:46. Only 14 minutes ago, humans have tamed fire. 11:59:20. The evening of the last day of the cosmic year, the 11th hour, the 59th minute, the 20th second. The domestication of plants and animals begins. An application of the human talent for making tools. (11:59:35). Settled agricultural communities
evolve into the first cities. We humans appear on the cosmic calendar so recently that our recorded history occupies only the last few seconds of the last minute of December 31st. In the vast ocean of time which this calendar represents, all our memories are confined to this small square. Every person we've ever heard of lived somewhere in there. All those kings and battles, migrations and inventions, wars and loves, everything in the history books happens here, in the last 10 seconds of the cosmic calendar.
We on Earth have just awakened to the great oceans of space and time from which we have emerged. We are the legacy of 15 billion years of cosmic evolution. We have a choice. We can enhance life and come to know the universe that made us, or we can squander our 15 billion year heritage in meaningless self-destruction. What happens in the first second of the next cosmic year depends on what we do, here and now, with our intelligence and our knowledge of the cosmos.